Since the dawn of human consciousness, we have looked up at the stars and asked questions about our beginnings. We have built massive telescopes to peer back in time, tracing the origins of our expanding universe all the way to the violent, fiery birth of the Big Bang, 13.8 billion years ago. But there is a question that is far more terrifying and far more profound than how it all started. The question is, how does it all end? Before we travel to the very edge of eternity, make sure to subscribe to the channel and join us on this journey. We are exploring the deepest mysteries of the cosmos, and you will not want to miss what lies ahead. Everything in the universe, from the smallest subatomic particle to the largest supermassive black hole, is governed by the laws of thermodynamics, and the most unforgiving law of all states that nothing lasts forever. Entropy, the measure of chaos and decay, always increases. The universe was born, it is currently living, and one day it will inevitably die. Cosmologists and theoretical physicists have spent decades running the mathematics of general relativity and quantum mechanics to predict the ultimate fate of reality. Depending on the exact nature of dark energy and the total mass of the cosmos, the mathematics reveal three terrifying, inevitable scenarios for the end of time. Let us begin with the most widely accepted and arguably the most chilling prediction in modern physics: the Big Freeze. To understand the Big Freeze, also known as the heat death of the universe, we must look at what the universe is doing right now. Since the Big Bang, the universe has been expanding. For a long time, scientists believed that the combined gravity of all the galaxies would eventually slow this expansion down. But in the year 1998, astronomers made a shocking discovery. The expansion of the universe is not slowing down. It is accelerating. An invisible, completely unknown force that we call dark energy is actively pushing the fabric of space-time apart, making the universe grow faster and faster every single second. If dark energy continues to push at its current, constant rate, the universe will not tear itself apart, nor will it collapse. It will simply expand forever, growing infinitely larger, infinitely darker, and infinitely colder. This process will not happen quickly. The death of the universe will be an agonizingly slow fade to black, playing out across 4 distinct eras of cosmic time. Right now, we live in the first era, the Stelliferous Era. This is the era of starlight. The universe is rich with glowing clouds of hydrogen, actively giving birth to new stars. Galaxies are bright, planets are warm, and life is possible. But this era is just a brief, blinding flash in the overall lifespan of the cosmos. In about 100 billion years, the expansion of the universe will become so extreme that the light from distant galaxies will no longer be able to reach us. From the perspective of the Milky Way, the rest of the universe will simply fade into absolute blackness. Eventually, the raw materials required to make new stars will be completely exhausted. The massive, bright blue stars will burn out first. The yellow stars, like our Sun, will swell into red giants, swallow their planets, and then shed their outer layers, leaving behind dead, glowing cores known as white dwarfs. The last stars left alive will be the red dwarfs. These tiny, incredibly efficient stars can burn for trillions of years, but eventually, even they will run out of fuel. In roughly 100 trillion years, the very last star in the universe will flicker, cool down, and die. The era of starlight will officially end, and the universe will plunge into the second stage of its demise, the degenerate era. The universe is now a graveyard. There is no new light. The cosmos is populated exclusively by the corpses of dead stars, white dwarfs, neutron stars, and black holes. These dead stars will drift through an endless, expanding ocean of absolute blackness. The white dwarfs will slowly lose their residual heat, radiating it away into the freezing void over quadrillions of years, until they become completely cold, pitch-black spheres of solid carbon. We call these theoretical objects black dwarfs. During the degenerate era, the universe will be impossibly cold and completely silent. Occasionally, two dead stars might randomly collide in the dark, sparking a brief, violent explosion that lights up the void for a few weeks before fading back into the eternal night. But even these dense, dead stars are not immortal. According to some theories of particle physics, the very building blocks of matter are unstable. Protons, the fundamental particles that make up the nucleus of every atom, might eventually decay. Proton decay. This process is unimaginably slow. It is estimated that it would take 10 to the power of 34 years for a proton to decay into lighter subatomic particles and radiation. That is a 1 followed by 34 zeros. But in a universe that has infinite time, everything that can happen will happen. Over this incomprehensible time span, every single black dwarf, every neutron star, every dead planet, and every piece of frozen dust will simply dissolve. The atoms themselves will fall apart. When the last atom in the universe dissolves into radiation, the degenerate era will end. The only physical objects left in the entire cosmos will be the ultimate cosmic predators. The black hole era. The universe is now completely unrecognizable. There are no atoms. There is no solid matter. The only things that exist are supermassive black holes scattered across an impossibly massive, expanding void. But as we explored in a previous journey, not even black holes are truly eternal. Because of the quantum mechanical process discovered by Stephen Hawking, black holes slowly leak energy. They emit Hawking radiation. They evaporate. Because black holes are so massive, this evaporation is the slowest process in the entire physical universe. To completely evaporate a supermassive black hole with the mass of 1 billion suns, it will take roughly 1 Google years. A Google is a 1 followed by 100 zeros. It is a number so large that there are not enough atoms in the observable universe to write it out on physical paper. But slowly, surely, the black holes will shrink. As they reach the final microscopic moments of their lives, they will violently detonate, releasing a sudden, blinding flash of energy into the dark. One by one, across the infinite expanse, the last surviving monuments of gravity will explode and vanish. When the final supermassive black hole evaporates, the universe will enter its final, permanent state. The Dark Era. This is the end of time. The universe is completely empty. There are no black holes, no stars, no atoms. The only things that exist are a few scattered photons of light, a dilute gas of subatomic particles, and completely flat, empty space. The temperature of the universe will reach absolute zero. Because everything is perfectly evenly distributed and there is no heat left to transfer, entropy reaches its absolute maximum. Nothing can ever happen again. There is no energy to do work. There is no way to measure time because there are no events to count. The universe is dead. It will remain in this frozen, empty state for the rest of eternity. This is the Big Freeze. It is a terrifying, lonely, and mathematically flawless end to everything. But it is not the only theory. What if the dark energy pushing the universe apart does not remain constant? What if the dark energy actually gets stronger over time? This leads us to the second scenario, a violent, sudden end to reality. The Big Rip. In this theoretical model, a specific type of repulsive force called phantom dark energy begins to exponentially increase its power. Right now, dark energy only acts on massive cosmic scales, pushing galaxies away from each other. The gravity holding our Milky Way together is strong enough to resist it. But if phantom dark energy continues to accelerate, it will eventually overpower all other forces in nature. About 22 billion years from now, the dark energy will become so powerful that the gravity-holding galaxy clusters together will fail. The Milky Way will be violently torn apart, its stars scattered into the expanding void. A few months before the end, dark energy will overpower the gravity of individual stars and planets. Our solar system will be ripped apart. Earth will be violently detached from the Sun and flung into deep space. A few hours before the end, the electromagnetic force holding solid matter together will fail. The Earth itself will shatter into billions of pieces. And in the final fraction of a second, dark energy will overpower the strong nuclear force. The very atoms that make up reality will be ripped apart into pure energy. The fabric of space-time itself will shred. The universe will end in a violent, catastrophic tearing of reality. But there is one final scenario, a scenario that offers a strange, cyclical sense of hope. What if dark energy eventually weakens? What if gravity eventually wins? The Big Crunch. If the expansion of the universe eventually slows down and stops, the combined gravity of all the billions of galaxies will take over. For a brief moment, the universe will stand completely still, and then it will begin to fall back in on itself. The universe will begin to shrink. Galaxies will rush toward each other. The cosmic microwave background radiation will become compressed, heating up the vacuum of space. Eventually, the universe will become so small and so hot that the stars themselves will be incinerated by the background heat of space. Galaxies will merge into a single, unimaginable supercluster of fire and gravity. Supermassive black holes will collide, merging into one single, universal black hole. In the final moments, all the matter, all the light, and all the space in the universe will be crushed back down into a single point of infinite density, a singularity. Reality will collapse back into the exact same state it was in before the Big Bang. Some physicists believe that this is not an end, but a reset. They theorize that the crushing weight of the Big Crunch could trigger a quantum bounce. The singularity will violently explode outward, creating a brand new universe. The Big Bounce. A cyclical universe. If this theory is true, our universe is just one in an endless, eternal chain of universes, born in fire, expanding, collapsing, and being born again, an infinite loop of creation and destruction. We will likely never know for certain which of these three fates awaits our cosmos. Whether we fade into the freezing dark, rip apart in a violent expansion, or collapse back into a singularity, the end of the universe is billions, if not trillions, of years away. Looking at the immense, terrifying lifespan of the cosmos, it is easy to feel small and insignificant. But you shouldn't. We are living in the Stelliferous era. We exist at the exact perfect moment in cosmic history when the universe is filled with light, warmth, and the heavy elements required to build planets and life. Out of an eternity of cold, empty darkness, we are alive during the universe's most beautiful, brief springtime. The universe may be destined to die, but right now, it is alive, and it is looking back at itself through our eyes. Thank you for joining me on this incredible journey to the end of time. If you appreciated this deep dive into the cosmos, please leave a like, subscribe to the channel, and turn on notifications so you never miss an adventure. Keep looking up